These are your guided notes for lesson 5.1, ratios and rates. In your I can statement line there, you want to write in I can simplify ratios and write a rate as a unit rate. I can simplify ratios and write a rate as a unit rate. Important definitions. Ratio is a comparison. Tough to squeeze that in there. Ratio is a comparison of two quantities using division. Example, 3/4, 3/4, 3:4. Essentially fractions, but also you can write it with the word 2 in between them or a colon in between the two numbers. You don't have to just use a fraction bar. A rate is a ratio, but it's a ratio that has two quantities with different units. So the units will be different. So in a ratio, the units will be the same, and with a rate, the units will be different. So as you can see here, 60 miles for every 2 hours. When one of the units is miles, one of the units is hours. So that's a rate instead of a ratio. A unit rate is a rate when but a unit rate is when the denominator is 1. So up here, 60 miles over 2 hours, that's a rate. And then if we get the denominator to be 1 by dividing it by itself, so 2 divided by 2 is 1, and you'd also divide the top number by 2, 60 divided by 2, you would get 30, and then you would have 30 miles over 1 hour, which we would simply write as 30 miles per hour. So in that blank there, we want the denominator of 1. First task, again, understanding the difference between a ratio and a rate. Example 1, there are 45 males and 60 females in a subway car. That's a ratio. A rate example would be the subway car travels 2.5 miles in 5 minutes. So you can see writing it as a ratio, even though it's males and females, it's still humans, so it's the same units. And then it can be simplified, divided both by 15 to get 3/4. Finding the speed of the subway car. So again, the example they gave us was 2.5 miles in 5 minutes. So we would put the 2.5 over 5. And then again, a unit rate is when the denominator is always 1. Currently it is 5. And so to get a number to be 1, we just divide it by itself. So since we've got a fraction form there, then that means we would need to divide both the top number and the bottom number by 5, which you can use your calculators to help you out. 5 divided by 5 would give us the denominator of 1, and then 2.5 divided by 5 would give us 0.5. And then we would write it out with all the proper labeling. So we would write 0.5 miles per minute. 0.5 miles per minute. You can also use a ratio table to find your rate. Main thing to keep in mind here when you see these tables, it's almost flip-flop the way that you would write the fraction. The top number in the table will actually end up being the bottom number in the fraction, and the bottom number in the table will end up being the top number in the fraction. So you can see that here. They wrote cost over amount, which is the opposite of how it is in that table. Eventually we'll get into output over input, or y over x. So we want to keep everything consistent as we build our way up to those future concepts. So it says use a ratio from the table to find the unit rate. So these are all proportional, so you can use any of them that you want. These two would go together, go together, go together. Just would make the most sense to use the smaller numbers here, so 25 and 100. So again, it's cost on top. Cost is 100, and amount on the bottom, it's 25. And then again, we would divide to get the bottom number to be 1. So we divide them both by 25, and we would get 4 over 1. And then we would write it out with all the proper labeling. So we would write $4 per square foot. All right, changing the rate to a unit rate. Denominator is 1. Complex fraction. So everything remains the same with what we've been doing. Complex fraction has at least one fraction. In the numerator, denominator, or both. So if we look at the graph there, they give us two ordered pairs, 1/2, 1/4, and 3, 1 1/2. So it says choose and interpret a point on the line. Let's start by using 1/2, 1/4. So again, they want us to find the speed in miles per minute. So that means that we should have miles on top and minutes on the bottom. If we want to know per minute, per means 1 minute. So we want the bottom number to be minutes. Just got to be careful with your ordered pairs, remember. An ordered pair is always your x value, comma, and then your y value. So when we look at 1/2, 1/4, the x is the 1/2 and the y is the 1/4. And if we look at the graph over here, we remember here's your y, you can see it right there, and here's your x right there. So our x, 1/2, is our minutes, so it needs to go on the bottom, and our miles, 1/4, is the y value, so it needs to go on the top. So we would have 1/4 on top over the number of minutes, which is 1/2 of a minute, on the bottom. And then nothing changes, so that's called a complex fraction because it has at least one fraction in there. But ultimately, again, we want a denominator of 1. So we have the 1/4 of a mile over 1/2, or 1/4 of a mile over 1/2 of a minute. And we want to know how many miles per minute. So again, to get the bottom number to be 1, you just divide it by itself. And if you divide the bottom by 1/2, you also have to divide the top number by 1/2. So anything divided by itself is always 1. So 1/2 divided by 1/2 gives us 1. And then we would do 1/4 divided by 1/2. So 1/4 divided by 1/2. And then just remember your rules for dividing fractions. Your first fraction would stay the same. Division becomes multiplication. 1/2 becomes 2 over 1. And you multiply straight across. So 1 times 2 is 2. And 4 times 1 is 4. And 2 over 4 is 1/2. So we get 1/2 on top and 1 on the bottom. So then we write it out with all the proper labeling. So we would write 1/2 mile per minute. Writing it all out. That's unit rate. Then again, this next part here goes with that same problem. It says use the point 3, 1 1/2 to find the speed of the subway car. Does your answer change? Explain your reasoning. So again, this goes back with the same problem. We're just using this ordered pair now, 3, 1 1/2. So again, the x3 would go on the bottom. The 1 1/2 would go on the top. We want the bottom number to be 1, so we divide it by itself. 3 divided by 3 gives us the 1 that we want. And then we have to do 1 1/2 divided by 3. So 1 1/2 as a fraction would be 3 over 2. And we're dividing that by 3. So 3 over 2 would stay the same. 3 as a fraction would be 3 over 1. Division becomes multiplication. 3 over 1 becomes 1 over 3. Multiply straight across, we get 3 over 6, which simplifies to 1/2. So again, we get 1/2 over 1. So just like we did here, we got 1/2 over 1, which is a 1/2 a mile per minute. Using that same, the ordered pair also on the line here. Okay, using another ordered pair that's on that line, we get the same thing, a 1/2 over 1. So we would write it out as 1/2 mile per minute. And it says, does your answer change? Our answer is no. And explain why. The reasoning is because the two ordered pairs are proportional. The speed of the train stays the same. All right, mixing paint colors. So you got, you mix a 1/2 cup of yellow paint for every 3/4 a cup of blue paint to make 15 cups of green paint. How much yellow paint and blue paint do you use? So there's some processes and steps that you could use to solve this, but remembering it would prove to be difficult. So the easiest thing to do would just be just work your way up. So if I had 1/2 cup of yellow and blue, I had 3/4, and then I just keep working my way up. So I add a 1/2 to the 1/2, that would give me 1 cup of yellow, and 3/4 plus 3/4 would give me 1 and a 1/2. So if I mix a 1/2 cup of yellow and 3/4 of a cup of blue, then to keep that same ratio, I would have to add 1 cup of yellow with 1 and a 1/2 cups of blue. Just keep adding halves. So again, for the yellow, 1 and 1/2. And then for the blue, add 3/4 to that would be 2 and 1/4. And then yellow, add a 1/2 again. That would give me 2 for the yellow. And for the blue, add 3/4. That would give me 3. So I can see now, right here, this would equal 5 total cups. 5 total cups. So 2 cups of yellow to 3 cups of blue would give me 5 cups total of green paint. So I need to get to 15 total cups of green paint. So if I have this as 5 cups, I can just multiply that by 3 to give me 15. So I just multiply these two numbers here by 3 as well. So the 2 times the 3 would give me 6 cups of yellow, and 3 times 3 would give me 9 cups of blue. And if you can see 9 cups of blue and 6 cups of yellow would give me 15 cups of green. So I just worked my way up. You can continue counting, adding 1/2 to the 2 to get 2 1/2, adding 3/4 to the 3 to get 3 3/4. But once you see the pattern, then you can just break from it and find your answer. So our answer says, how much yellow paint and blue paint do you use? You use 6 cups of yellow and 9 cups of blue to make the 15 cups of green. So the try it your own problems now, you can certainly use all of these numbers I have for the 15. They want to know how much yellow paint and blue paint to make 20 cups. And then try these problems on your own here. Simplify 25 to 45. Simplify 35 girls to 15 boys. You're finding your unit rate. So remember, these you want to have a denominator of 1. Number 5, use the ratio table to find the unit rate. So again, and don't forget, we flip these around when we write them as a fraction. So the feet, 7.2, would go on top, and the years would go on the bottom. Generally, time will always go on the bottom. Minutes, years, hours, that's always going to be on the bottom. Weeks, days, months, time will always go on the bottom. And then you got one with a graph, gives you an ordered pair, 4, 122. So again, remember, it's always x, y, but when you write the fraction out, you always want the y on top and the x on the bottom. And then an exit question, why do you think rates are usually written as unit rates? So do the rest of those problems for homework.